in a world where getting to low Earth orbit is expensive and payload is very limited. So we solved it. Ceres will be carried to 40,000 feet in the air by two jumbo jets, where it will detach from the carriers and with thrusters on, it will reach low Earth orbit. All this taking only 36% the fuel used by a traditional space shuttle launched vertically in the orbit. All this reducing cost of fuel and allowing payload to be increased as weight of fuel is significantly decreased. See, the idea has been into working before us, but never done in a massive scale or used commercially. This sounds very utopian and very difficult to implement, but trust me, we have the numbers to back it up.
Did somebody say numbers? Oh boy, let's get right into it. Ceres will be carried up to and dropped from a height of 40,000 feet, or about 12,200 meters. This means that the acceleration of Ceres towards the center of the Earth will be 9.7 meters per second squared. The rocket itself will be launched in two phases. Burning about 5,000 kilograms of fuel a second in its first stage, Ceres will accelerate until reaching a velocity of 11.9 kilometers a second, a whole 0.8 kilometers a second higher than the required escape velocity at that altitude. Of the 780,000 gallons of fuel on board, Ceres will require at max 500,000 gallons to reach lower Earth orbit, with a payload capacity of 200,000 kilograms. Armed with a top-of-the-state guidance system, Ceres will, in the middle of freefall, position itself vertically upwards so as to begin accelerating the instant that it is dropped. But
what will it look like? Starting off with its size, it will be roughly as big as a SpaceX Falcon 9, with a height of 230 feet and a diameter of 12 feet. Moving on, there will be two stages to the rocket, and Ceres will be carried up to 40,000 feet in the atmosphere. Its propellant tank walls and domes being made from an aluminium lithium alloy. The rocket will contain grid fins to increase accuracy and precision. Inside the ship, there will be a flight deck in the front, followed by a research facility, and behind it being the crew quarters and a payload area. With the back of the ship containing the engine room, back fuel stage, and at the end, the back thrusters. The tip of Ceres having forward thruster and fuel stage with the electrical and main system. But certain models of Ceres will have different interior depending on its application, providing comfort and luxury for space tourists, while some models provide research facilities and increased payload area to get resources and machinery into orbit. The color of course being white with the Indian flag near the front of the ship.
So, now that the basic structure of Ceres has been explained, we have made a real-life physical model after it to give you a better idea of how Ceres will be. This will be the rocket that will detach from the two jumbo jets at 40,000 feet and will reach low Earth orbit.
unlike its predecessor, the Pegasus, Ceres will reach lower Earth orbit as a product of its vertical velocity alone. This means that the fuel save by not going horizontally is roughly 36% of what Pegasus would have used.
There was a problem, we gave a solution. All this leading to easier and cheaper space travel. Idea is there, we just need resources. Thank you so much for this opportunity.